All right, welcome back. This lesson is called Arithmetic and Geometric Series. Now, I've put the definition on the board. Definition of a series. Okay, so on the board is written, a series is the sum of a set of range elements of what? A sequence. Now, in order to understand series, you have to first understand sequence. So if you have not watched the previous videos on sequence, I recommend that you watch those first. I do start covering the concept of series in those videos. But a series is the sum of a set of range elements of a sequence. So on the board I've written an example of an arithmetic sequence. Why is this arithmetic? Well, remember, arithmetic means adding. Adding what? What are we adding to get to the next number? To get from 1 to 2, we're adding 1. To get from 2 to 3, we're adding what? 1. To get from 3 to 4, we're adding 1. Because we're adding 1 to get to the next number, this is called what? Arithmetic sequence. Notice the commas. This is a list of numbers. Let's circle these numbers. Remember from the previous videos that these are what? These values are the range of the sequence. Now, down here I'm going to write arithmetic series. What is the difference? Okay, so a series is a number, a value. Okay, think of sequence as a list of numbers that goes on forever. A series is a specific value or a sum of these numbers. Now, we're not going to add all of them forever. We're just going to stop at 10. So I want you to write, arithmetic series is the sum of a set of these. We're going to add the first 10. So a series is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, so we have to figure out what this value is. We're going to add the first 10. What you are looking at is a series. A series is the sum of a set of range elements of a sequence. Now, this has a specific value. We're going to find this value. But my question is, before we go forward, the ... Can you add forever? Can you add forever and get a value? I ask this to students every year. Can you add forever and get a value? And many look at me and say, no. No, you can't add forever and get a value. But the answer is actually yes. And we're going to see this coming up soon. Yes, you can add forever and get a specific value. Not this. But is there a way to add forever and get a specific value? The answer is yes. Now, you don't want to have to add all these numbers up. You have on the test, you won't have a calculator. So you're going to be spending, what if I ask you to add the first 100 of these? Okay, how long is it going to take you to add 100 numbers? You say, that's going to take a long time. Well, okay, so the rumor goes like this. Einstein was in elementary school. Okay, he was in the 4th or 5th grade. And he's misbehaving in class. And so the teacher says, what can I come up with to keep Einstein busy? So he tells Einstein, he says, hey, go to the back of the classroom, and I want you to sit down and add all the numbers from 1 to 100. Okay, go to the back of the class, add all the numbers from 1 to 100. And so Einstein turns around, takes 2 steps, and goes, but wait a minute, isn't that 5,050? And the teacher looks at him and goes, how'd you do that? There's a trick. Okay, Einstein figured this trick out. Okay, so what is the trick to adding these numbers? You don't have to add them all up. You can do this in your head. The answer to this is 55. Okay, and how do we do this? I'll show you. Okay, so look. If it is arithmetic, meaning that the values are increasing by 1, or the values are increasing by 3, or whatever, you're looking at an arithmetic series. Okay? Add the first number and the last number. Okay, so we're going to look at 1 plus 10. What is 1 plus 10? It's 11. I'll write it on top. 1 plus 10 is 11. Now, let's look at 2 plus 9. What is 2 plus 9? 2 plus 9 is 11. What is 3 plus 8? Well, 3 plus 8 is 11. What is 4 plus 7? 4 plus 7 is what? 11. And what is 5 plus 6? 11. Do you notice that these values are what? These values are going down by 1 as these values are going up by 1, making a constant sum. Now my question is, notice, we have how many 11s? How many 11s? We have 1, 2, 3, 4, 5 11s. So all you have to do is what? 11 times what? 11 times 5 and get what? 55. The sum of these numbers is 55 if you add them up. 10 plus 9 is 19, plus 8 is 27, 34, 40, 45, 49, 52, 54, 55. Okay, so you can add them up or you can use this trick. Now what is the trick? Let's look at this. Why did we get 5 11s? Why did we get 5 11s? Because we paired them up. My question is, how many numbers did we have to start with? Well, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 10 of them. Okay, how many numbers did it take to make 11? How many numbers did it take to make an 11? It took 2. If it takes 2 numbers to make an 11, and you have 10 numbers, if it takes 2 numbers to make one 11, and you have 10 numbers, how many 11s will you end up with? Hopefully you can see 10 things divided by 2 is 5 pairs. We're pairing the numbers up to make an 11. So every time we pair a set of numbers, we get 11. So every pair of numbers makes an 11. So how many pairs of numbers are we going to have that will make 11? You're going to have 5 pairs making 5 11s. Okay, so we end up with what? 11 times 5. So what is the trick here? The trick is this. Let me show you. The trick is what? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. The trick is this. Add the first number and the last number. What's the first plus the last? 1 plus 10 is what? 11. Now, how many numbers are there in the list? This is important. There are 10 numbers in the list. If we have to pair them up to make 11, how many pairs will we have making 11? We're going to have exactly half of 10. So the trick is this. Add the first number and the last number, which is what? 1 plus 10 makes 11. And multiply the 11 by half as many numbers as you have. Now notice, you have 10 things that you're adding. What is half of 10? Or take 10 and divide by 2. 10 divided by 2 is what? 5. So we get 11 times 5 is what? 11 times 5 is 55. And this is our trick for adding what? Arithmetic series. Now, on your tests and on your quizzes, your series will be written in a different format called sigma notation. Again, this was introduced in previous videos. So if you haven't watched the previous videos, make sure you watch those first. Sigma n equals 1 to 10 of 2n plus 3. We're going to work this problem. Sigma n equals 1 to 10 of 2n plus 3. Now I tell students this again. Think of this as a step ladder. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we have all numbers from 1 to 10. And each of these numbers is going to go in for n. So we're going to put in 1 for n. We're going to put in 2 for n. We're going to put in 3 for n. We're going to put in 4 for n. We're going to put in 5 for n. And keep going until we put in what? 10 for n. So the last number that we put in will be 10. So I want you to write underneath this. This is a really easy problem. I want you guys to write underneath this 2 times what? We're putting in what for n first? We're putting in 1 for n. So I want you to write 2 times what? 2 times 1 plus 3. And now what are we putting in for n? We already put in 1. Now we're going to put in what? 2. So write 2 times what? 2 plus 3. And now what are we putting in for n? We're putting in what? 3 for n. 2 times 3 plus 3. And now what are we putting in for n? We're putting in 4 for n. So 2 times 4 plus 3. That's enough. That's enough. You're going to see a pattern here. You're going to see a pattern and you're going to be able to write the rest of your numbers. So calculate these. Okay, so 2 times 1 plus 3 is what? 2 times 1 is 2 plus 3 is 5. 2 times 2 is 4 plus 3 is 7. 2 times 3 is 6 plus 3 is 9. 2 times 4 is 8 plus 3 is 11. Do you see a pattern in these numbers? What's happening each time going from 5, 7, 9, 11? What's happening? Well, hopefully you say the numbers are increasing by what? The numbers are increasing by what? They're increasing by 2, increasing by 2, increasing by 2. Okay, if they're increasing by 2, let's go ahead and write them. Equals, right? Equals 5, 7, 9, 11. What's happening in the list? The numbers are increasing by what? The numbers are increasing by 2. Since the numbers are increasing by 2, we said if the numbers are increasing by a certain value, we call this what? Arithmetic. So this is an arithmetic series that you're looking at. This is an arithmetic series. What does sigma mean? What does sigma mean? Sigma means what? Add. So we're adding 5 plus what? Here, let's get rid of the plus 2 so it doesn't confuse. All right, we're just adding 2 to get to the next number. But sigma means add all of these numbers up. So 5 plus 7 plus 9 plus 11 plus what? What's the next number? Just continue in the same pattern. You don't have to calculate all of these. You can just calculate the first few and figure out a pattern. What's the next number? 11 plus what? Plus 13 plus, keep adding 2 to get to the next number. Plus what? Plus 15 plus what? 17 plus, hold on. We want to know where we're stopping. We want to know where we're stopping. Where are we stopping? We're stopping when we put in what for n? When we put in 10. So I want you to calculate the last value. Put in 10 for n. We get what? If we put in 10 for n, we get what? 2 times 10 plus 3. 2 times 10 plus 3 is 20 plus 3 is what? 23. So where are we stopping? We're stopping when we get to 23. So we have plus 17 here. Let me write this a little smaller. 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus what? 17 plus 19 plus 21 plus. Where are we stopping? We're stopping when we get to what? 23. Plus 23. Now, how many numbers are we adding up? Let's look. What is n going from? N is going from what? 1 to 10. How many numbers do we have to plug in? We're plugging in 1, 2, 3, 4, all the way up to what? 10. How many numbers are there from 1 to 10? There are 10. Question. How many numbers are there from 1 to 10? There are 10. How many numbers are there from 0 to 10? From 0 to 10, there are what? 11. Okay, there are 11 numbers from 0 to 10. Again, 1 to 10 is 10. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers from 1 to 10. How about 0 to 10? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11. So how many numbers are there from 0 to 10? There are 11. Okay? So I need you guys to be paying attention to how many numbers are listed. How many values of n are you plugging in? You're plugging in what? There's 10 of them that you're plugging in. So how many numbers will there be in this list? There are 10. Okay, so 1, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that all of them? Yes, you know that that's all of them because you calculated where you're stopping. You calculated where you're stopping by putting in 10 for n. 2 times 10 plus 3 gave 23. Now, is this arithmetic? Yes, we've established that this is arithmetic. Why? We've established this arithmetic because to get from one value to the next, to get from 5 to 7 is to add 2. To get from 7 to 9 is to add 2. So since we're adding to get to the next number, this is arithmetic. Go ahead and write on top, arithmetic. Now, if this is arithmetic, there's a trick. I want you to diagram the trick. What is 5 plus 23? 5 plus 23 is what? 28. Diagram it again. What is 7 plus 21? 7 plus 21 is what? 28. What is 9 plus 9 plus 19? 28. What is 11 plus 17? 28. And what is 13 plus 15? 28. How many 28s do we have? 1, 2, 3, 4. There are 5 28s. Why are there 5 28s? Because it took two numbers to make a 28, and there were 10 numbers in the list. So again, what is our trick? For adding arithmetic sequences, instead of adding all these numbers up, because on the test I'm going to ask you to add 100 numbers. Okay, you cannot add 100 numbers quickly. You're going to be spending your whole test adding if you don't know this trick. So in order to add this set of numbers very quickly is to do what? Add the first number, which is 5, to the last number, which is what? 23. So 5 plus 23 gives what? 28. And we multiply 28 by how many pairs do we have? Well, we had 10 numbers in the list. How many numbers are there from 1 to 10? There are 10. There are 10 numbers in the list. Okay, since we're pairing them up to make a 28, we take 10 numbers and divide by 2. What is 10 divided by 2? 10 divided by 2 is 5. So again, the trick is take the first number and add the last number, you get what? Take the first number, which is 5, add the last number, 23, we get 28. Multiply this by half the numbers that are in the list. Since you had 10 numbers in the list, half of 10 is what? 5. So you get 28 times 5, which is 140. So our answer, or our sum, is 140. If you add all these numbers, you get 140. All right? If you want to check that, you can take a calculator and you can add them up. Okay, to check that, it's 140. Let's look at another one. Sigma. N equals 0 to 10. N equals 0 to 10. Be careful, be careful. How many numbers are there from 1 to 10? There are 10. How many numbers are there from 0 to 10? There are 11, so we're going to have to be careful here. 0 to 10 of what? Let's do 3n minus 1. 3n minus 1. So what do we have to calculate? We have to calculate the first few values to find a pattern. Okay, so I want you to plug in, what's the first value we're plugging in for n? We're plugging in what? 0. So we get what? 3 times 0 minus 1. Plug in the next n value. So n is going from what? 0 to 10. So plug in 0, plug in then what? Plug in 1, plug in 2, plug in 3, plug in 4. Okay, you only have to do the first 3. Plug in 0. We get 3 times 0 minus 1. Now plug in 1. We get what? 3 times 1 minus 1. Now plug in 2 for n. We get 3 times 2 minus 1. Okay, what is this? 3 times 0 is 0 minus 1 is negative 1. Okay? Now 3 times 1 is 3 minus 1. 3 minus 1 is 2. Now 3 times 2 is 6. 6 minus 1 is 5. What's happening each time? Look at your numbers. What's happening each time? The numbers are going up by what? To get from negative 1 to 2, we're going up by what? Up by 3. To get from 2 to 5, we're going up by what? Up by 3. So if you follow the same pattern, you can write your numbers out very quickly. We have negative 1, 2, 5. Do not put commas. Do not put commas. Commas lose you points on the test. Commas are for sequence. We're putting what? We're putting addition. Guys, what does sigma mean? Sigma means what? Sigma means add. Okay, so we're adding. So negative 1 plus 2 plus 5 plus what's the next value? Keep going up by 3. So 5 plus 3 is what? 8. Plus, go up by 3 again. What's the next number? 11. What's the next number? Go up by 3 again. 14. What's the next number? Go up by 3 again. 17. Hold on. We need to know where we're stopping. We need to know where we're stopping. Where are we stopping? Well, how do we figure out where we're stopping? We put in the last number. We put in 10 for n. Put in 10 for n, we get what? 3 times 10 minus 1, which is what? 30 minus 1, which is 29. Okay, so we're stopping when we get to 29. So keep going. 17 plus what? 20 plus what? Go up by 3 again. 23 plus what? 26 plus 29. We stop when we get to what? 29. Now count the numbers. Count the numbers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many numbers are there from 0 to 10? There are 11. Count the numbers up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many numbers are there from 1 to 10? There are 10. Okay, so there are 10 numbers from 1 to 10. There are 11 numbers from 0 to 10. How do we figure this out? The trick is this. Subtract. Take 10 subtract 1. What is 10 subtract 1? Well, 10 subtract 1 is 9. Now add 1. So 10 subtract 1 is 9. Now add 1. We get 9 plus 1 is 10. There are 10 numbers from 1 to 10. Here, subtract and add 1. What is 10 minus 0? 10 minus 0 is 10. Now add 1. That's what? 11. So how many numbers are there from 0 to 10? There are 11. All right, so we're looking at 11 numbers being added together. What is the trick here? The trick is to do what? Add the first number, add the last number. So we have to take negative 1 and add that to 29. Negative 1 plus 29, be careful. Negative 1 plus 29 gives what? 28. And we're going to multiply the 28 by half as many numbers as there are in the list. How many numbers are there in this list? Well, we've already established that there are 11 numbers in this list. What is half of 11? So you count. Okay, so we take the first plus the last. Negative 1 plus 29 gives 28. And we multiply this by half the numbers that are in the list. Since there are 11 numbers in the list, half of 11 is what? Half of 11 is 5.5. Let me help you with this. Okay, half of 11. Half of 11. Well, what's half of 10? Half of 10 is 5. And what's half of 12? Half of 12 is 6. Okay, if half of 10 is 5 and half of 12 is 6, what's half of 11? Since 11 is between 10 and 12, half of 11 is 5.5. So we're going to do 28 times 5.5, and you set this up. 28 times 5.5 to multiply decimals. We ignore the decimal. Treat this as 28 times 55. 5 times 8 is 40. Carry the 4. 5 times 2 is 10 plus 4 is 14. We do it again. 5 times 8 is 40. We put a 0. Carry the 4. 5 times 2 is 10 plus 4 is 14. We add. We get what? 0, 4, 5, 1. So we get 1540. Now we count. How many decimal places did we have? Well, we had one number. I should say, how many numbers were past the decimal? There was one number past the decimal. So we're going to come in one decimal place and put a decimal here. So our answer is what? 154. 28 times 5.5 is 154. Another way to do this, I want to show you, this is a better method. And I don't want to confuse, but I want you guys to see this trick. To do 28 times 5.5, well, here, maybe it's better if I show you. Okay, let's do the first plus the last. Okay, what is negative 1 plus 28? I'm sorry, negative 1 plus 29, we get what? Negative 1 plus 29 is 28. Write that. And now do 2 plus 26. What is 2 plus 26? 28. Write this. What is 5 plus 23? 28. And what is 8 plus 20? We get 28. And what is 11 plus 17? 11 plus 17 is what? 28. So far, how many 28s do we have? 1, 2, 3, 4, 5. And what are we left with? We're left with what? 14 by itself. And what is 14? 14 is half of 28. So do you see that we have 1, 2, 3, 4, 5 28s and half of a 28? So to do this, watch. To do 5.5, I'm going to erase this over here. To do 5.5 times 28, 5.5 multiplied by 28, a better way to think of this, and I think this gives you a visual, is to do what? Well, you can break this up. You can do 5 times 28 and you can do half of 28. 5 times 28 and half of 28. Okay, so 5 times 28, 5 times 28, if we multiply this, we get 140. And then we have to figure out what half of 28 is. Half of 28 is 14. Okay, just take 1 half times 28 means take 28 and divide by 2. So half of 28 is 14. Now add these. 140 plus 14 gives what? If we add these, we get what? 154. I think that's a better way of thinking through it. All right, so let's go ahead and look at some more problems. All right. Okay, so sigma n equals 0 to 10 of, here, 2n plus 3. Okay, so what are we plugging in for n here? We're plugging in what? We're plugging in 0, we're plugging in 1, we're plugging in 2, we're plugging in 3, we're plugging in 4, all the way up to 10. So I want you guys to plug in 0. 2 times what? 2 times 0 plus 3. 2 times 0 plus 3. Now plug in 1. 2 times what? 1 plus 3. On the test, I want you guys to write the first 3. 2 times what? 2 times, plug in what? We plugged in 0, we plugged in 1, now we're going to plug in 2. 2 times 2 plus 3, and find a pattern. Find a pattern. 2 times 0 is 0 plus 3 is what? 3. 2 times 1 is 2. 2 plus 3 is what? 5. 2 times 2 is 4. 4 plus 3 is 7. What's happening to the numbers, right? Equals, what's happening to the numbers? The numbers are going up by what? Going up by 2. I want you to notice something. What is in front of n? What is in front of n? 2. Do you see mx plus b? Or do you see a slope? Remember, slope is the same as what? Slope is the same as common difference. Or what is happening each time? The values are going up by what? Going up by 2. It's the number in front of n. The values are going up by 2. It's the number in front of n. So if you look here, you should have been able to find your first value, which was 3. Know that the sequence is going up by what? Going up by 2, the number in front of n. So we have what? 3, then what? 5, then what? 7. I should say, I think I said sequence. I meant series. Sometimes I say those backwards, guys. Series. The series values are increasing by 2. So 3, 5, 7, then what? 9. What does sigma mean? Sigma means what? Add. So we're going to put plus, plus, plus. 9 plus what? 11 plus what? 13 plus, hold on, we need to know where we're stopping. We need to know where we're stopping. Okay, so we need to know where we're stopping. We're going to plug in what? Plug in 10 for n. So 2 times 10 plus 3 gives what? 20 plus 3 is 23. So we're stopping when we get to 23. So we have 13 plus what? 15 plus what? 17 plus 19 plus 21 plus 23. Now, first, before we get started on finding the sum, we need to know how many numbers are in this list. How many numbers are in this list? What do? We subtract. We do 10 minus 0. 10 minus 0 is what? 10. Now add 1. That's what? 11. There's 11 numbers in this list. 10 minus 0 here. 10 minus 0 is what? 10. Now add 1. What is that? 11. There are 11 numbers in this list. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You must know how many numbers there are in the list. Now we're going to take what? The first number and add what? The last number. What is 3 plus 23? 3 plus 23 is what? 3 plus 23 is 26. Okay, so add the first and the last, and we're going to multiply by what? Multiply by half the numbers that we have in the list. Since there were 11 numbers in the list, half of 11 is what? Half of 11 is 5.5. So we're going to multiply by what? 5.5. Now I told you guys a fast way to do this is to take what? 26 times 5, and also do 26 times half, or half of 26. 26 times 5 gives 130, and half of 26 is just divide 26 by 2, is what? 13. Now add these. 130 plus 13 gives what? 143. Okay? So we get 143 as a sum. Now, let's look at another problem. Sigma, this is just like a test question. We're going to use K. K equals 3 to 15. K equals 3 to 15 of 4 minus n. K equals 3 to 15 of 4 minus n. All right. So notice, what was in front of n up here? What was in front of n up here? There was 2 in front of n. So what's happening to the values? The values are increasing by what? The values are increasing by 2. Notice, what is in front of n here? Circle it. What is in front of n? There's a negative 1 in front of n. This means that the values are going to be going down by 1 each time. I'll show you. If you're not sure, calculate. Always calculate the first 3. I'm going to require this, that you guys calculate the first 3 on the test. So 4 minus what? Oh, why do I do this? I always do this. Okay, I put k here. Guys, if I use k here, k has to be used here. I do this all the time. Okay, if k here, k here. If n here, n here. Same thing. Does it matter whether we use n and n or k and k? No, but I always make a mistake. I always make a mistake of putting k here and n here. That's wrong. It has to be k and k or n and n. Now, so plug in what? Plug in 3 for k. Be careful. We're not plugging in 0. We're plugging in what? We're plugging in 3 for k. So we have 4 minus what? 4 minus 3. Okay, now we're going to plug in what? We're going to plug in 4 for k. We put in 3, put in 4, put in 5, put in 6, put in 7. Okay, so plug in 4 for k, we get what? 4 minus 4. Plug in 5 for k, we get what? 4 minus 5. Okay, so 4 minus 3 is 1. 4 minus 4 is what? 0. 4 minus 5 is what? Negative 1. All right, so this is equal to, what's happening to the values? The values are going down by what? We can even do another one. We can put in 3, we can put in 4, we can put in 5, we can put in 6. 4 minus 6 gives what? Negative 2. What's happening to the values? The values are going down by what? They're going down by 1. What's the number in front of k? Same thing as the number in front of n. Okay, the number in front of n was 2. The values were going up by 2. The number in front of k is negative 1. The values are going down by what? Going down by 1. So go ahead and write 1 plus, remember sigma means add, 1 plus 0 plus negative 1 plus negative 2 plus negative 3 plus negative 4. Keep going down by 1. Plus negative 5 plus, hold on. We need to know where we're stopping. How do we find where we're stopping? Well, we plug in what? We plug in 15. So plug in 15. We do 4 minus what? 4 minus 15 gives? 4 minus 15 gives negative 11. So we're stopping when we get to negative 11. So we have negative 5 plus what? Plus negative 6 plus negative 7 plus negative 8 plus negative 9. If you do not put the addition, guys, you lose points. So make sure you put the addition. Plus what? Negative 10. Where are we stopping? We're stopping when we get to what? Negative 11. Now, I want you to figure out, before counting these, how many numbers are there in this list? How many numbers are there in this series? Okay, let's figure it out. What do? Up here we did what? We did 10 minus 0. 10 minus 0 gave what? 10 minus 0 gave 10, then we added 1 to get 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, same thing here. We're going to do 15 subtract 3. 15 subtract 3 gives what? 12. Now add 1. 12 plus 1 is what? 13. How many numbers are in this list or in this series? There are 13. Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 13. Now, the trick is always to add what? The first and the last. Add the first and add what? The last. So we're going to do 1 plus negative 11. Okay, what is 1? Well, we can do this in our head. 1 plus negative 11. 1 plus negative 11 gives what? Negative 10. Okay, so we add the first and the last, and we multiply by what? Multiply by half the numbers that are in the list. Since there are 13 numbers in the list, you do 13 divided by 2. 13 divided by 2 gives what? Well, 12 divided by 2 is 6. 14 divided by 2 is 7. Since 13 is between 12 and 14, okay, half of 13 is 6.5. So we have negative 10 times 6.5 gives what? Negative 10 times 6.5 gives, move the decimal. When you multiply by 10, it's very easy. Move the decimal one time, and we get what? Negative 65. Okay, so the sum of this thing is negative 65. Now, what could we do here to save time? Now, on the test, if I say 3 to 15, you will be required to write out all the numbers. But really, to find the answer, negative 65, all we had to calculate was what? All we had to calculate was our first value and our last value. Okay, so all you really had to calculate was the first value and the last. What does that mean? You had to plug in 3 and you had to plug in 15. Find your first, find your last is all you really need to do to find the answer. So if you're on the SOL trying to solve this problem, all you have to do is find what? Your first and your last. So let's plug in 3. Plug in 3, we get 4 minus 3 gives what? 1. Now plug in our last, 15. Okay, we get 4 minus 15 gives what? 4 minus 15 gives negative 11. This is our first, right? First. This is our last, right? Last. And all we have to do is add what? First and last. 1 plus negative 11 gives what? Negative 10. And multiply that by half the numbers that are in the list. Since there are, well, 15 minus 3 gives what? 15 minus 3 gives 12. Add 1. Since there are 13 numbers in the list, half of 13 is 6.5. So we're going to take our sum of our first and our last and multiply by half of 13. Half of 13 is what? 6.5. We get what? negative 65. So that's really all you had to do, except for the fact that on the test, I will ask you to write out the entire sum. So you will write out the entire sum, and then you will find the value of the series, okay, or the sum of the series. Now, except for one question. There will be one question on the test like this. I'm going to erase all this. There will be one question on the test where I ask you to add 100 things. Okay, so if I ask you to add 100 things, add 100 numbers together. Am I going to expect you to write everything out, the entire list of numbers? No. Okay, so this will be the only exception. The directions will be very specific. So if I say sigma n equals 1 to 100 of 2n plus 3. If I say n equals 1 to 100 of 2n plus 3, then you are adding how many numbers? How many numbers are there from 1 to 100? There are 100 numbers from 1 to 100. So all you have to do here is find your first and your last. So to find the sum, just find your first. What are we going to do to find our first? We're going to plug in 1 for n. So we're going to get what? 2 times 1 plus 3. 2 times 1 plus 3 is what? 2 plus 3 is 5. Find our last. Put in 100 for n. So we get 2 times what? 2 times 100 plus 3 is what? 203. Now, this is our first. Circle it, write first. This is our last. Okay, circle it, write last. This is our first number, 5. This is our last number, 203. We're going to add our first and our last. Okay, so 5 plus 203 gives what? 208. Okay, so we're going to add our first and our last. 5 plus 203 gives 208. And we're going to multiply this by what? Multiply this by half the number of numbers that are in the list. How many numbers are there from 1 to 100? How many numbers are there from 1 to 100? Okay, there are 100. Now, half of 100 is what? 50. Okay, so we're going to go 208 times 50 gives 1,040 add a 0. So we get 10,400, I believe. 5 plus 200, yeah, 1,040 add a 0. So we get 10,400. This is just a matter of you multiplying 208 times 50. Now, be careful, be careful. What if I write this, okay? Sigma k. Now, if I use n, it's n. If I use k equals... If I use k, it's going to be k. Let's do this one. Okay, so k equals 0 of, let's say, 3n plus 2. 3n plus 2. So what do you have to do here? You have to multiply what? I'm sorry, you have to find what? You have to find your first and your last. First and last. So what are we doing? Be careful. What are we plugging in to find our first? We're plugging in... What did I just do? I did it again. Okay, if this is k, this is what? This is k. I always do that. I don't know why. I always make that mistake. So if this is k, this is k. If this is n, this is n. If this is k, this is k. All right, does not matter, but these have to match. So on the test, I say this. If I make a mistake and I put k here and n here, all you have to do is say there is no answer and you get full credit for the question. So if I make a mistake writing the test question, if I make a mistake like that where I put k here and I put n here, guess what? You get a perfect grade. You get a 10 out of 10 if you write there is no answer. Okay, so just understand. If you understand that this has to be k and k, if I make a mistake, you can write there is no answer and get full credit for that question. All right. Put in 0 for k. We get what? 3 times 0 plus 2, which is what? 0 plus 2 is 2, so our first value is 2. And now put in our last number. Our last number is what? 100. So we get 3 times 100 plus 2 is what? 300 plus 2 is 302. And now what are we going to do? Circle them, write first, write what? Last. Okay, first and last. And what are we going to do with our first and our last? We're going to add them. So we get 2 plus 302 is what? 304. So we get 304, and we're going to multiply by half the numbers that are in the list. Now be careful. How many numbers are there from 1 to 100? There are 100. Okay, how many numbers are there from 0 to 100? There are 101. So you're going to have to say, all right, subtract them and add 1. Take 100 minus 1, what do you get? 100 minus 1 is what? 99. Now add 1. What is that? We get 100. There are 100 numbers in the list. You take half of 100, you get 50. Now, to go from 0 to 100, there's 101. Hopefully you already know this by now, just from discussion. But take 100 minus 0. 100 minus 0 is what? 100. Now add 1. What is that? 101. Now, half of 101. Half of 101. You may have to divide by 2. Half of 101 is what? 2 goes into 101 5 times. Well, 2 goes into 10 5 times. We get 10. Subtract. We get what? 0. Bring down the 1. 2 does not go into 1, so we put a 0. We get what? Remainder 1. Or how about we do this? How about we not do a remainder? Well, yeah, that's fine. We bring down the 1, we get what? a 1, remainder of 1 and 1/2. So 50 and a half or 50.5. Okay, so half of 101 is 50.5. Hopefully you can figure that out. Okay, 50.5. So 304 times 50.5 has to be calculated. Okay, I'm just going to tell you. 5 times 3 is 1,520 out of 0. So we get 1,520. 1520. 5 times 3 is 1,520 out of 0. Plus half of 304 is 152. So we get 150, yeah, 152. So 15,352. 15,352. 15,352. 5 times 3 is 1,500. 5 times 4 is 20. It's 1,520 out of 0. 1,520 out of 0. 15,200. Half of 304 is 152. Yeah, this is 15,352. All right, so 15,352. Okay, so you will calculate this. You can multiply this out. You can multiply this out as 304. I'll just show you. 304 times 50.5. Okay, I expect that you guys can multiply. 5 times 4 is 20. 0 carry the 2. 5 times 0 is 0 plus 2 is 2. 5 times 3 is 15. Now 0 times 4. Remember we start one decimal place in. So 0 times 4 is 0. 0 times 0 is 0. 0 times 3 is 0. Start two decimal places in. 5 times 4 is 20. 0 carry the 2. 5 times 0 is 0 plus 2 is 2. 5 times 3 is 15. We add, we get what? 0, 2, 5, 3, 5, 1. Now, we had how many decimal places to, how many numbers past the decimal place? We had 1, so we're going to come in one decimal place. We get what? 15,352. Okay, so our value matches. Value matches. Now, all of this was arithmetic. Notice, what was happening to go from 3 to 5? What was happening to go from, we were adding 2. To go from 5 to 7, we were adding 2. This was all what? Everything you've looked at is arithmetic. Okay? So arithmetic, the trick is what? Arithmetic, the trick is to add what? The first and the last and multiply by half the number of terms. Now, let's look at a new type of sequence that does not have a trick. This new sequence is geometric. Okay? And how are we going to recognize geometric? We're going to recognize, go ahead and write geometric. We're going to recognize geometric series. Not, I keep saying sequence, I mean series. Okay, series. Geometric series is recognized by an exponent. So I want you guys to write sigma n equals 1 to 5 of 4 times 2 to the n minus 1. 4 times 2 to the n minus 1. Now, we have to plug in same thing, except we're only adding up 5 values. Okay, so there's no trick for these, but the cool thing about the geometric series is all I'm going to ask you to do on the test is add, say, the first 5 from 1 to 5. So it's pretty simple. We're plugging in what? We're plugging in 1, we're plugging in 2, we're plugging in 3, we're plugging in 4, we're plugging in 5. So I want you to write 4 times what? 4 times 2. What's going in for n first? Notice we have an exponent. How do we know the difference between geometric and arithmetic for now? I want you to know geometric means what? There's an exponent. Okay? Notice n is acting as what? An exponent. With arithmetic, n is not acting as an exponent. Okay? So for arithmetic, when n is not acting as an exponent, you have this trick of adding the first and the last. With geometric, there is no trick. You just have to add them up. Watch. So we're writing what? 4 times 2 to the what? What's going in for n first? We're putting in 1. Okay, so we get what? 1 minus 1. Now we're going to plug in 2 for n. So we get 4 times 2 to the what? Plugging in 2 for n, we get what? 2 minus 1. Now plug in what? Plug in 3 for n. So we get 4 times 2. 4 times 2 to the what? 3 minus 1. Now plug in 4 for n. So we get 4 times 2 to the what? 4 times 2 to the 4 minus 1. Plug in 5 for n. We get what? 4 times 2 to the what? 5 minus 1. Now, the order of operations says, please excuse my aunt. Okay, you guys have, remember this acronym. We do what? Parentheses first. Parentheses first. Look inside your parentheses. Or my question is this. Here. Do we do 4 times 2? Do we do 4 times 2 first? No. Do we do 4 times 2 first? No. We don't multiply first. Multiplication is done late. Okay, what do we do first? We do parentheses first. Look inside the parentheses. Is there anything that needs to be done inside the parentheses? No, so cross it out. What's the next thing that we do? We do exponents next. So look, do we have an exponent? Yes. Cross out the 1 minus 1. Let's fix the exponent. 1 minus 1 is what? 0. Cross out the 2 minus 1. What's 2 minus 1? 1. Cross out the 3 minus 1. 3 minus 1 is 2. Cross out the 4 minus 1. What's that? 3. Cross out the 5 minus 1. What's that? 4. We fix all the exponents. 0, 1, 2, 3, and 4. Now, And we're actually going to skip the minus 1 part. In the future, when we put in a 1, we're going to do this in our head. Put in a 1, 1 minus 1 is what? 0. We put in a 2, 2 minus 1 is what? 1. We put in a 3, 3 minus 1 is 2. We put in 4, 4 minus 1 is 3. And we put in 5, 5 minus 1 is what? 4. So we can just skip the step of writing the minus 1. Now, we're going to start with what? We're going to start with the exponent. What are we going to do? 2 to the 0. Before we do this, I need to remind you, what is 7 to the 0 power? 7 to the 0 power is 1. What is 8 to the 0? 8 to the 0 is 1. What is 192, or 127.3? How about 127.3 to the 0? What is this? 1. What is negative? What is negative? What is negative 169.3 to the 0 power? What is this? Quantity, negative 169.3 to the 0 power is what? 1. Anything to the 0 power is what? Anything to the 0 power is 1, except, be careful, what is 0 to the 0? What is 0 to the 0? Okay, this is indeterminate. This is going to be huge for what's coming in this class. You must know this. Okay, indeterminate. This makes no sense. 0 to the 0 is indeterminate. This makes no sense. But anything else, I say this, anything to the 0 power is 1, except for what? 0 to the 0. Okay, 0 to the 0 is indeterminate. So going back over here, what is any number to the 0 power except for 0? Well, what is 2 to the 0 power? It's 1. Okay, 2 to the 0 power is 1, so we get what? We get a 1 times the 4, so we do the multiplication last. 4 times what? 4 times 1 is 4. Now the next one. Next one we have to do 2 to the first. What's 2 to the first? Well, 7 to the first is 7. 8 to the first is what? 8. Okay, so 2 to the first. 2 to the first is what? 2. So we end up with 4 times what? 4 times 2, which is what? 8. Now, we have to do what? 2 squared. 2 squared. What does 2 squared mean? 2 squared means 2 times 2, which is what? 4. So we end up with what? 4 up front. 4 times what? 4, which is 16. Now what do we have to do? We have to do 2 to the third. What is 2 to the third? 2 to the third is what? Well, it's not 6. Okay, I ask students this all the time. What is 2 to the third? No, 2 to the third is not 6. What is 2 to the third? 2 to the third is 2 times 2 times 2. Multiply 2 by itself 3 times. You're not multiplying. 2 to the third does not mean multiply 2 times 3. What does it mean? It means multiply 2 times itself 3 times. 2 times 2 is 4 times 2 is what? 8. Okay, so we get 2 to the third is 8. So we end up with 4 times 8, which is what? 32. Now, lastly, 2 to the fourth. 2 to the fourth is what? 2, here, write it again. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is what? 16. Here's a trick. What's 2 times 2? 4. What's 2 times 2? 4. What's 4 times 4? 4 times 4 is what? 16. So we end up with what? 4 times 16, which is 64. Now, notice, we've calculated all of our values. Circle them. 4, 8, 16, 32, 64. What does sigma mean? Sigma means what? Sigma means add, so we're going to add them up. So we have 4 plus 8 plus 16 plus 32 plus 64. Add them up. Add them up. So there's no trick here. You cannot do your first and last. Let me show you. What is 4 plus 64? What is 4 plus 64? That's 68. What is 8 plus 32? That's 40. These don't match. There is no trick here. You cannot add your first and your last and use a trick. No, you just have to add these up. There is no trick for what? There is no trick for geometric. How do we know that we're looking at geometric? When there's an exponent. All right, when n is acting as the exponent. So just add them up. 4 plus 8 is 12, plus 16 is 28, plus 32 is 60, plus 64 is 124. 124, yeah, that's right. All right, let's do another one. Let's do another one. Okay. Looking at here, sigma, k equals 1. Now, if this is k, over here has to be k. I always make this mistake. K equals 1 to 5 of 4 times 1/2 to the k minus 1. Good, so I didn't mess this up. Okay, so if this is k, that is k. They have to match. Okay, so 4 times 1/2 to the k minus 1. Okay, so what do we have to figure out here? We have to plug in what? We have to plug in 1, plug in what? Plug in 2, plug in 3, plug in 4, and plug in 5 for k. So let's write it out. 4 times 1/2 to the what? 4 times 1/2 to the... Do this in your head. If we plug in 1, what do we get? We plug in 1, we get 1 minus 1, which is what? 0. Okay? Now, 4 times 1/2. 4 times 1/2 to the what? Plug in 2 for k. 2 goes in for k. 2 minus 1 is what? 2 minus 1 is 1. Now, 4 times 1/2, and we're plugging in what? 3 for k. Plug in 3 for k. 3 for k is 3 minus 1, which is what? 2. We get 4 times 1/2 to the what? 4 goes in. 4 minus 1 is 3. 4 times 1/2, plug it in. We plug in 5 for k. 5 minus 1 is what? 4. We just skip a step. So we do the subtract 1 in our head. Now, we start with what? We start with the x, or I should say, question, do we do 4 times 1/2? No. We do the multiplication last. What do we do first? We do the exponent first. 1/2 to the 0. What is 1/2 to the 0 power? Anything to the 0 power is what? 1, except for 0 itself. 1/2 to the 0 is 1, so we end up with 4 times 1, which is what? 4. Now, 1/2 to the first. What is 1/2 to the first? Well, if 7 to the first is 7, and 8 to the first is 8, what is 1/2 to the first? 1/2 to the first is 1/2, so we end up with what? 4 times 1/2, and you can do this. You can number times fraction, we always do what? Divide first. So do 4 divided by 2. 4 divided by 2 is what? 2 times 1 is, 4 divided by 2 is 2 times 1 is what? 2. If you guys are struggling with fractions, let me explain something to you. Fractions cannot be a struggle. Soon in this class, we're practicing now. We've got to get these bugs worked out of fear of fractions. We have to get fractions down early. Look, soon in this class, you're going to be looking at this. X over x plus 1 plus 5x over x squared minus 1 over x squared plus 5x minus 6 over x plus 3. Monster-looking fractions, okay, in only 2 more weeks. So these are coming in 2 weeks. Do we have to practice with fractions? Yes. We have to get fractions down now. So the fractions have to become easy. They're not hard, guys. It's just a matter of practice. Fractions are 2 multiplication problems in 1. Let me show you. Again, 1/2 squared. What does this mean? We do the exponent first. Write it. 1/2 multiplied by 1/2. Okay, so just look at this as 2 multiplication problems in 1. What are we going to do? We're going to multiply our top, multiply our bottom. What's 1 times 1? 1 times 1 is what? 1. What's 2 times 2? 4. Let's just multiply the top, multiply the bottom. Multiply the top, multiply the bottom, we get 1/4. So what is this? 4 times 1/4. And now we do number times fraction, we divide first. Divide first if possible. Can we do 4 divided by 4? Yeah. 4 divided by 4 is 1. 1 times 1 is what? 1. Now, we have to do 1/2 to the third. Okay, 1/2 to the third means 1/2 times itself 3 times. So write 1/2 times 1/2 times 1/2. Question, what is this? Students tell me all the time that this is 3 over 6. No, we are not adding. What are we doing? We are multiplying. We are multiplying. You are multiplying your top. 1 times 1 times 1. We are not adding. We're not doing 1 plus 1 plus 1 and getting 3. No, multiply. 1 times 1 is what? 1 times 1 is 1. Now multiply your bottom. We're not adding 2 plus 2 plus 2 and getting 6. No, we're multiplying. 2 times 2 is what? 2 times 2 is 4 times 2 is what? 8. So we get 1/8. So we end up with 4 times 1/8. 4 times 1/8. Now, can we do 4 divided by 8? No, we cannot do 4 divided by 8. So instead, there's a trick here. This always comes out as a trick. Geometric, there's always tricks. You can cancel. Do you see this as 4 over 1? Hopefully you say yes. Now, we don't write over 1, but do you see that we have multiplication? When there's multiplication, we can cancel. We can cancel top with bottom, numerator with denominator, top with bottom. We can cancel the 4 on top with the 8 on the bottom. Now, 4 cancels with 8, leaving what? Now, we don't need to write the over 1. You should see that 4 is on the top. Do you see that 4 is on the top? Hopefully you say yes. So divide them both by the same thing. 4 divided by 4 is what? 1. Do we have to write the 1? No. 8 divided by 4 is what? 2. So we don't even have to write the 1. Anytime, 1s are not written. They're redundant and they make things look messy. So we don't write 1s. 4 divided by 4 is 1. We don't write it. 8 divided by 4 is 2. We get what? 1 over 2. Now, lastly, 1/2 to the 4th. 1/2 to the 4th. So we're going to write what? 1/2 times 1/2. Stepping back so you can see 1/2 to the 4th. 1/2 times 1/2. So 1/2 times 1/2 times 1/2 times 1/2, we're multiplying. 1 times 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 is 8. Times 2 is what? 16. So we get 4 times what? 4 times 1 over 16. And we cannot divide 4 by 16. We cannot divide 4 by 16, so instead we cancel. We cancel. What divides 4 and 16? 4. 4 divided by 4 is 1. We don't write it. 16 divided by 4 is what? 4. So we end up with 1/4. Now, what does sigma mean? Sigma means what? Sigma means add. So we're going to add all these numbers up. Circle them. Add all these numbers up. So we get what? 4 plus 2 plus 1 plus what else? Plus 1/2 plus what? 1/4. Hold on. Let me check and make sure that camera's working. Yeah, okay, the camera's working. I saw it for a reason for a minute there. I saw the light pop on and I thought it went off. Okay, so the camera's working. All right, so we're looking at Okay, there's a trick here. Add your fractions first. Always add your fractions first. Now, 1/2 plus 1/4. 1/2 plus 1/4. Addition of fractions is harder than multiplication. Addition is harder than multiplication. Remember, when we add, something must match, and what matches doesn't change. Something must match, what matches doesn't change. This phrase is going to be very important as well in this class. When we add, always remember, addition is harder than multiplication. Why? We always thought that addition was easier. It's not the case. Addition is harder than multiplication. Why? Because when you add, something has to match. Addition is going to make our lives more difficult in this class. You guys will see as we go on. Fractions are a good example. When we add, something has to what? Match. And what matches doesn't change. Okay, so what has to match? What has to match? The bottom, the denominator has to match. We have to make these match by making them larger. At least one of them larger. Now, we want to make them larger so that they match. Are we going to make the 4 larger? No. What are we going to make larger? We're going to make the 2 larger. How? By multiplying. Multiplying by what? Multiply by 2. If we do this to the bottom, we do this to the top. 2 times 2 is what? 4. 2 times 1 is what? 2. So we get 2/4 plus what? 1/4. And what matches doesn't change. What matches doesn't change. The 4s will not change. We get a denominator 4, add the top. 2 plus 1 is 3. So, question, what is in the box? What is in the box? What's in the box is equal to what? I'm going to erase all this so we have space. What's in the box is what? What's in the box is what? 3/4. So we get 3/4 plus all of this. All of this. 4 plus 2 is what? 4 plus 2 is 6 plus 1 is 7. So we have 7 plus 3/4, which gives 7 3/4. Now, you're saying, do I really have to do all this work on the test? No, this is actually really easy. Let me show you a trick. Okay, so watch this. Watch this. There is a trick here. There is a trick. I want you to notice something. What is the first value? What is the first value here? 4. What is the first value here? 4. Okay, look over here. What is the first value? What is the first value? 4. What is the first value? 4. What do we call this? We call this a sub 1. What do we call this? A sub 1. Okay, what is the first value? The first value is 4. We call this a sub 1. What is the first value? The first value is 4. We call this a sub 1. Now, what is this 1/2? The 1/2 is your R value. 1/2 is your common ratio, or what we're multiplying by. What is the value here? 2. What is this called? The R value, what we're multiplying by to get to the next term. So all you have to do is this. Watch. Let's redo this problem easier. I'm going to show you how easy this problem is. Watch. Redoing this problem underneath it. Here, let's get some space and do it underneath. This is all you have to do. Watch. So we had sigma n equals 1 to 5 of 4 times 2 to the what? 4 times 2 to the n minus 1. So all you have to do is this. Watch. What is your first value? The first value is 4. Put an a sub 1 above this. This is our first value. Now, above your 2, put r. This is your common ratio. Okay, so we're going to start with our first value. First value is what? 4. And now the common ratio is what we're multiplying by to get to the next number. What are we multiplying by to get to the next number? We're multiplying by what? 2. 4 times 2 is what? Times 2. 4 times 2 is what? 8. Now multiply by 2 again. We're multiplying by the common ratio to get to the next number. Times 2 is what? Times 2 is what? 8 times 2 is 16. Multiply by 2 again. Multiply by 2 again. What do we get? 32. Multiply by 2 again. What do we get? 64. Is this the same numbers? Yes. It's the same numbers. You didn't even have to do all that work. And what does sigma mean? What does sigma mean? Sigma means add. Be careful. Count them. Count them. 1 to 5. Be careful. What is this? A sub 1, A sub 2, A sub 3, A sub 4, A sub what? A sub 5. Yes, they're all there. All 5 of them. Sigma means what? Sigma means add, so we're going to put what? Addition, 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 addition. Add them up. 32 plus 64 is 96. This is 112 plus 8 is 120 plus 4 is what? 124. Is there a trick here to adding first and last? No. Why? Because we're looking at geometric. There's an exponent. All right, now look. Same thing here. Sigma k equals 1 to 5 of 4 times 1/2 to the k minus 1. There's a trick here. Again, find your first value. What is your first value? This is all you have to do for your test. What is the first value? The first value is 4. We call that a sub 1. What is the r value? The r value is what? 1/2. Okay, so the first value is 4. Write that. Right? Equals 4. And the r value is 1/2. This means what are we multiplying by to get to the next term? We're multiplying by what? We're multiplying by 1/2. So all you have to do is tell me what 4 times 1/2 is. 4 times 1/2. Again, 4 times 1/2, what are we doing? We're taking 4 dividing by 2. 4 dividing by 2. So 4 divided by 2 is 2 times 1 is 2. 4 times 1/2 is 2 times 1/2 again. Times 1/2 again. 2 times 1/2. 2 times 1/2 is what? 2 divided by 2 is 1 times 1 is 1. Times 1/2 again. Now this is easy. What's 1 times 1/2? Or what's 1 times anything? 1 times anything is itself. 1 times 1/2 is what? 1/2. Now, once we get the fractions, it's even easier. Once we get the fractions, it's easier. So we have a half multiplied by a half again. Okay, so half times half. We multiply top times top, bottom times bottom. So 1 times 1 is what? 1. 2 times 2 is 4. So when you have a half times a half, guys, it's easy. You do top times top, bottom times bottom. 1 times 1 is 1. 2 times 2 is 4. Okay? So once we get to fraction times fraction, it's actually really easy. It's just 2 multiplication problems. 1 times 1 is 1. 2 times 2 is 4. Now count. How many terms are we adding? How many numbers are there from 1 to 5? There are 5. So look. 1, 2, 3, 4, 5. Yes. Add them up. Add them up. What did I say? Add what first? Add what first? Add your fractions first. 1/2 plus 1/4. We've already established this to be what? 3/4. And now we add the numbers. 4 plus 2 is 6 plus 1 is what? 7. 7 plus 3/4 is 7 3/4. There's our answer. Let's practice another one. All right, sigma k equals 1 to 5, or, yeah, k equals 1 to 5 of 3 times negative 2 to the k minus 1. Okay? Same thing. All you have to do is find what? What is a sub 1? What is a sub 1? A sub 1 is what? 3. That's your first value, right? 3. What is your r value? Your r value is what? Negative 2. This is all you have to do for your test. Your r value is negative 2. So what are we multiplying by to get to the next term? We're multiplying by what? Negative 2. Be careful here. Multiplying by negative 2. So what is? What is 3 times negative 2? We get negative 6. Now, multiply by negative 2 again. Multiply by negative 2 again. Negative 6 times negative 2 is what? Positive 12. The signs are going to alternate from positive to negative to positive to negative. Multiply by negative 2 again. Multiply by negative 2 again. What is 12 times negative 2? We get what? Negative 24. Okay, do it again. Multiply by negative 2 again. Negative 24 times negative 2 is what? Positive 48. And careful, do we have all of our values from 1 to what? From 1 to 5? 1, 2, 3, 4, 5. Yes, they're all there. So put sigma means what? Add. There's a trick here. There's a trick here. Add your positive numbers first. Add your positive numbers first. 12 plus 48 is 60 plus 3 is 63. Add your positive numbers up first and cross them out. Cross them out. What do we get? 3 plus 12 is 15 plus 48 is 63. Okay, so cross the positive numbers out. Now add your negatives. Remember, if the signs are the same, you're adding. Negative 6 plus negative 24, the signs are the same, you add. Negative 6 plus negative 24 is negative 30. And notice, this becomes very simple. You're looking at 63 minus 30, which is what? 33. Okay? Now, a couple more and we're done. All right? Next one. We're not done with series yet. We're going to be looking at, can we add forever and get a value? That's coming up. All right, so looking at sigma, k equals 1 to 4. Well, here, let's do 1 to 5. 1 to 5 of 9 times 1/3 to the k minus 1. Okay, so question. We start with what? We start with our first value. What is our first value? Right above the 9, write a sub 1. This is our first value. Now, above the 1/3, write r. The r value, or the 1/3, the r value is always the number that lies underneath the exponent. Okay, so we have 9 is the first value. So we have 9, and what are we multiplying by each time? We're multiplying by a third. So 9 times a third. 9 times 1/3. Okay, again, you do 9 divided by the bottom. 9 divided by 3 is 3 times the top. 9 divided by 3 is 3. 3 times 1 is 3. Times 1/3 again. Times 1/3 again. So 3 times a third. We do 3 divided by 3. 3 divided by 3 is 1. 1 times 1 is 1. Okay? Times 1/3 again. 1 times 1/3. Well, 1 times anything is itself. 1 times 1/3 is 1/3. Now, times 1/3 again. Times 1/3 again. Once we get the fraction, it's easy. 1/3 times 1/3. Do top times top, bottom times bottom. 1 times 1 is what? 1 times 1 is 1. 3 times 3 is what? 9. So we get 1/9. Now, count. How many terms are we supposed to add up? We're supposed to add up what? 5. So 1, 2, 3, 4, 5. Yes, we have them all here. Add them up. And what did I say? It's always easier to start with what first? Start with your fractions first. Start with your fractions first. So 1/3 plus 1/9. When we add fractions, what do we need? When we add, something must match. So we need to find a common denominator. Something must match. What has to match? Denominator. We're going to make these match by making them larger. Are we going to make the 9 larger or the 3 larger? Hopefully you say the 3 needs to be larger, and we're going to do this by multiplying by what? Multiply by 3. If we do this to the bottom, we do this to the top. 3 times 3 is what? 9. So we get a denominator of 9. 3 times 1 is what? 3. So we get 3/9 plus what? 1/9. 3/9 plus 1/9. What matches doesn't change. The 9 does not change. Add the top. 3 plus 1 is what? 4. So we get 4 ninths. So we agree, 4 ninths, 4 ninths. What is in the box? What is in the box? 4 ninths. And what are we adding? The numbers now. 9 plus 3 is 12 plus 1 is what? 13 plus 4 ninths. What is 13 plus 4 ninths? We get 13 and 4 ninths. And that concludes, we're going to stop here. That concludes this video. So hopefully, today you understand that the series is what? A series is the sum of the range of a sequence. I introduced that at the beginning of the video. We're finding the sum. Here, look. What is 33? What is 33? 33 is a series. A series is a value. You can think of a series as a number. What is 63 minus 30? That's a series. What is 3 plus negative 6 plus 12 plus negative 24 plus 48? What is this? This is a series. And what is the sigma notation? What is the sigma notation? This is a series. All of these are the same thing. This is a series, which is the same as this, which is the same as this, which is the same as this. Okay, so you can think of series as sigma notation, a sum of values, or a number. Okay, so series is the sum of the set of a set of range elements of a sequence. Remember, one more thing, elements mean what? Numbers. All right, that concludes. Great.